Alright, so in this last part of the video analysis, we're going to have a look at the energy of the pendulum. And to do this, what we'll do is we'll change the plot view to 2. And we want a graph of gravitational potential energy and kinetic energy for the motion against displacement. So kinetic energy is easy, that's here. And we don't want it against time, we want it against displacement. So we can see that the kinetic energy at max displacement is pretty much 0. And at equilibrium it's a maximum, and then at max positive displacement it's 0 again. We want a second graph here of potential energy. So what we're going to do then is click this button and go down to define, and we want to add a data function, and this is going to be potential energy like so, and then we'll double click on expression, and potential energy is mass mgh, and the height that this thing reaches above 0 is just the y position, so it's going to be m and then times, which is asterisk, and then 9.81, which is g, and then times, and then the variable is y because that's our height above 0, and then we can hit enter. And we'll close that, and then we'll change this to potential energy against displacement. And we can see that this one kind of does the opposite. It's a little bit weird at the bottom here, but it kind of does the opposite of what this one was doing. I'm just going to bring it down a little bit. So now we can copy this. So go to edit, copy object, not object, image, and we'll choose plot view. Okay, a couple of little comments about these graphs. The potential energy here is not very accurate. So all you can really comment on about this are the corresponding shapes of them, and you can use that in your discussion of how energy changes are taking place